Okay, there are a lot of different characteristics of graphs. We could go through a list of all of them, but one particular characteristic of graphs that we're going to talk about today are called asymptotes. An asymptote for short, is a line in which the graph does not cross. All right, there's two types of functions that we're going to take a look at where we're going to end up with an asymptote, okay? So the first type of function that we're going to look at is called a rational function. And we've already taken a look at the domain and range of these rational functions. So what's tied closely to that domain and range of the rational function are the asymptotes. So let's just take a look at a quick graph here. Let's see if I can do this. Hang on. All right. So we got a little graph going. No big deal. Okay, so let's take a look at this graph here. What if I want to take a look at, so rational means fractional. So when I think rational, I think fractions. So the graph we want to look at, let's take a look at f of x equals, I don't know, let's call it 1 over x minus 4. Let's take a look at that. Okay, so the graph for 1 over x minus 4. We could create a table of values. Mind you, you can always create a table of values. But let's see, what would that table of values look like? So x and y. We get to choose the x values, right? We get to choose the input because it's independent. So I have the freedom to choose whatever x values I want to put in there. So I think we should start with, let's start with 0. Let's just see what happens. If I plug a 0 in, okay, so 1 divided by 0 minus 4 is 1 over negative 4, or a negative 1/4. Okay, if I plug a 1 in, what happens if I plug a 1 into this thing? I'm making it up. I don't know what x values I should choose. I'm just picking random x values. So if I put a 1 in there, so 1 over 1 minus 4. 1 minus 4 is a negative 3, so I'd end up with a negative 1/3. And if I plug a 2 in, 2 minus 4, so I'd have 1 over 2 minus 4, so I'd end up with a negative 1/2. And if I plug a 3 in, when I plug a 3 in, 1 over 3 minus 4, so 3 minus 4 is negative 1. 1 over negative 1 is negative 1. Now, if I plug a 4 into this, 1 over 4 minus 4 is 0. Remember, recall that anything divided by 0 is undefined. So when I plug a 4 in, it is undefined. All right, if I plug a 5 in, so 1 over 5 minus 4 is 1. So I'd end up with, 5 minus 4 is 1. 1 divided by 1 is 1, so I get a 1. If I plug a 6 in, 1 over 6 minus 4. So 6 minus 4 is 2. 1 over 2 is just a positive 1/2. And we can start to see a pattern develop here. These are all negatives, and these are all positives. So something weird is happening here at x equals 4. So 1, 2, 3, 4. Something weird is happening here. So let's plot some of these points. 0, it's at negative 1/4. So that's got to be, let's call it right there. And at 1, it's at negative 1/3. Let's call that right there. And at 2, it's at negative 1/2. There's 1/2 right there. At 3, it's at negative 1. Here's a negative 1. At 4, it's undefined. At 5, it's a 1. So 1 right here. And at 6, it's at 1/2. Right here. What you don't see is that the closer and closer we get to 4, the bigger and bigger the number is. So if we were to go through the exercise of plugging in all these really small decimals, like 4.01, what you'd end up seeing is that it's going to follow this really interesting trend here where it gets really, really, really close to 4, but it never actually touches 4. And it gets really close to 0, but it never actually touches 0. And on this side, it's going to get really, really close to 0. As the farther negative we get, the closer and closer we get to 0 without ever actually touching it. And the closer we get to 4, it gets really close to negative infinity. Now, looking at the domain and range, we've already practiced the domain and range of this guy, right? The domain are input values. I can have an x value, anything, but I cannot have an x value of 4. So here the domain, x cannot equal 4. And the range, in our range, our y values, it starts at negative infinity. I cannot have a 0, but it goes all the way to positive infinity. So here, my range, y cannot equal 0. Now, this is what I like the most. Let's see. Let's try green. This line right here, right along the x-axis, you can't really see that, huh? Right along that x-axis, we get really close to it, but we never actually touch. Well, an asymptote is a line in which the graph does not cross. So here, is this graph actually going to cross the x-axis? No. So this has a horizontal asymptote. So it's a horizontal asymptote of y equals 0. And then there's a vertical line here. It should be a dash, not a solid line. It should be dash line. And it has a vertical asymptote right through here at x equals 4. So it has a vertical asymptote of x equals 4. Okay. So it would be nice if I didn't have to build this every single time, right? If I could just look at this and decide, woo, where is that going to be? Well, it's kind of easy to look at this and do that because of this information that we have here. I cannot divide by 0, right? So let's take a look at another example. I want you to find the domain, range, vertical, and horizontal asymptotes for the following. And let's call it f of x equals 1 over x plus 2 minus 3. So the domain and range, vertical and horizontal asymptote for these values here. Okay, so what ends up happening here, what I cannot have is that I cannot have 0 at the bottom of the fraction. So here, I cannot have a 0 as the bottom of that fraction. So I'm going to take that denominator, and I'm going to say that x plus 2 equals 0. Subtract 2 from both sides. X here cannot equal negative 2. So that tells me automatically now I know my domain, x cannot equal negative 2. Then we want to figure out what the range is. The domain, the range, vertical and horizontal asymptotes. Now, what this does, this graph, if we were to look at this, just this graph, not the minus 3, but just this part, 1 over x plus 2. Look what happened here. 1 over x minus 4 sent everything to the right. I was on x equals 4, right? And here I have x plus 2. My domain cannot equal negative 2. So I know I would have a vertical asymptote at negative 2. So it moved it a couple to the left. So this -3 business, if I plugged in, let's say I plug in -1, okay? If I plug in a -1, 1 over -1 plus 2, -1 plus 2 is 1, so 1 over 1 is 1. If I take 1 and I subtract 3 from it, I'm going to take 1 and I'm going to go down 3 units, right? So I would go down 3 units. It's like taking this shape right here, and it would be at -2. The vertical would be at -2, and then it would go down 3 units. So the horizontal would be at -3. So a quick outline of that graph, just a quick little, hey, what up? Let's take a look at the visual here. Just a visual. We know that at -2, we're going to have an asymptote at -2 because the denominator can't equal -2. So vertical asymptote there. And then shifting down, we're going to move this thing down 3 units. So it's going to go here. We're going to have a horizontal asymptote here. So that graph, really close to it, and go that way. This one's going to come in really, really close to it, and then break down that way. Okay, so now we can see the range quite easy, right? The range, y cannot equal -3. Now let's say the vertical the vertical asymptote. So our vertical asymptote is the line x equals -2. So x equals -2. And our our horizontal, asymptote, this one here crosses the y-axis at -3. So that is going to be y equals -3. Now, asymptotes are lines. These are lines, and they must be presented in the form of an equation. All right, lines. All lines must be presented in the form of an equation.